Okay, so this is the last video for class 9 maths exercise and 13.5. Okay, and this has no test for this. These are examples that we're going to do. We'll start with example 11. You can go to textbook page 243. Okay, let me read the question for us. A wall of length 10 meter was to be built across an open ground. The height of the wall is 4 meter and the thickness is 24 centimeter. So let us draw that first. So there is a wall. Let's suppose this is the wall, okay? We know it's always cuboidal in shape, so we may draw it this way. And the length is very clearly given as, I think, 10 meter, yes. And the thickness means the thickness of the wall is given as 24 centimeter. Please notice that this is meter and then this is centimeter, so we have to match the units, okay? And then the height of the wall is mentioned as 4 meter high, so here 4 meter. So let us write here dimensions of the wall. Dimensions of the wall. Okay, here the length is very clearly mentioned, 10 meter. Now let us change it to centimeter here itself, kilometer, so that it will match up. Hectometer, meter, decimeter, centimeter, millimeter. Okay, so we need to change here meter to centimeter. Why we are doing this is because I think that will be easier, because the dimension of the brick also, if you read, will be in centimeter. Okay, so let us change the meters to centimeter. So if you want to change meter to centimeter, you're changing big to small, right? So 1 plus 10, another 10, so 10, 10, double 0. So at the back of this 10 will come to 0, then meter will go away, and centimeter. Okay, so this is your length of the wall. Okay, then breadth is 24 centimeter. That is the breadth of the wall. Or they're saying thickness. So let us just use the same word. I think thickness is a better word because, yes, so thickness. It means the breadth only. And the height of the wall is 4 meters. So like we have done for 10 meter, multiply to double 0. Then because you're changing 10, 10, so 100, right? So 2 zeros at the back of 4 means meter will disappear and centimeter will come. You need to memorize this and keep it in your mind, okay? Because you'll be keep on needing it from time to time, okay? So that is the dimension of the wall. Now, the bricks that are going to be used are 24 into 12 into 8. So there's a cuboidal brick here. So the brick will be smaller in size, and these are going to make up the walls. So 24 centimeter long, 12 centimeter broad, and the height or the thickness is 8 centimeters. So dimensions of each brick, dimensions of each brick, okay, BRICK. So small l, let us use 24 centimeter, that's fine. That is the reason why we change this to centimeter, because it can match up, because unless they're in the same unit you can't simplify together, right? So cancel and all. Breadth is 12 centimeters, so this is the width or the breadth of the brick, and the edge here is 8 centimeter. This is the thickness or the height of the brick. You can just use height. So therefore, the question is asking us, look there please, and then it says how many bricks would be required to build this size of wall. So that will be required, okay, required numbers of brick that will be required, okay. Required numbers of bricks will be volume of the wall that you're going to build, volume of wall divided by volume of each, means 1, okay, 1 brick. That will give you the answer for the number of bricks that you need to bring in order to build this wall, okay. So here that will be equal to volume of the wall is cuboid, capital LBH, brick is small letters we have used, so we can put that. So it's just a matter of calculating it. So this will be 1000 into 24 into here 400. As you can see here, 1000 into 24 into 400. We need to use the centimeter, so it will match up with the brick. So volume is 3-dimensional, we know that. So centimeter cube. Small LBH is 24 into 12 into 8, again centimeter cube. As you can see here, small L, B and H values. So we can just cancel up this centimeter cube and centimeter cube. And then here 24 and 24 can cancel. Okay. Then 8 5s are 40, 0 can cancel. Okay, 2 6s are 12 and 2 2s are 4, 1 in hand, 25. And 2 3s are 6 and 2 5s are 10, 0 0. You can do that. No more can cancel. So 5 5s are 25, 5 2s are 10, 11, 12. And 2 zeros here, just put it divided by 3. This will give you the number of bricks. Okay, so we divide this one 12500 is divided by 3. 3 4s are 12, no remainder, 5. 1s are 3, 2, and then 0 comes down. Then 3 6s are 18, 2 remain, 1 more 0 come down. Okay, 3 6s are 18, and then 2 remain, point and 0. 3 6s are 18. Since we are calculating the number of bricks, you can just stop there after first decimal, okay? And write it once, 4166.6, this many bricks. But we know that number of things cannot be in decimal. How many students are there in your class? To answer that question, you cannot say 22.5 students. That's absurd, right? Doesn't make sense. So we have to change it to whole number. So 416, how do you do that? Check the number after decimal. If that first place of decimal is 5 or more than 5, let this increase by 1. So this becomes 7. Suppose it was 3 lesser than 5, something like that. It would have been 4166 bricks. Okay, so approximately, not exact now, but 4167 bricks approximately. So you can just add your word APP there, approximately. So that is your first answer. Okay, example 11. Let us go to the next one. Okay, example 12. You'll find this on textbook, page 244. Okay, 244. So please go there. Okay, let me read the question for us. Okay, let me read. A child playing with building blocks, which are, as you can see on your textbook, of the shape of the cubes, has built a structure as shown in figure 13.25. If the edge of each cube is 3 centimeter, find the volume of the structure built by the child of the shape of cubes. Okay, and they're same edge. So the child seems to be playing with a cube like this. 1, okay, as you can see in the diagram. And then he placed 2 here. Very clearly it can be seen. So you can just draw a line there. Then here, there, 2. So he's placing here 2. And next he's placing 3. So let us just go there. So there, placing 3. Again 3. So you can continue to draw. Okay, 1, 2, and 3. Then next he placed 4. So you can just continue to draw. 1, 2, 3, and 4. Then here, let's complete the cube. There. And then finally, if you check the diagram properly on the text, it's given like this 5 cubes, same size he put it last year. These were 1, 2, 3, 4, and 5. So finally, just complete the cube here at the top. So this is the structure that the child has built by placing these cubes of the same edge. Okay. So you may want to draw it nicely, then just draw it. Sorry. Okay. So here, this is the structure. Now we have here, okay, A equal to 3 centimeter, I think, if I'm not wrong, the edge of each cube, yes, is the edge. It's supposed to be the edge, H-E-D-G-E, edge means the side, okay, edge or side of each cube, okay, that the child is playing with. Now, since, as we can see the structure, there are 15 cubes in this structure that a child has built, or in the structure, you can mention the way you like it. In this structure we see here 15. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Therefore, the question is asking us, find the volume of the structure. So you can just write here. So volume of this structure or the structure, whichever way you want to put it, will be therefore volume of one of this cube that the child is playing will be h is a, so a cube formula, right? And then there are 15 such cubes, so you can multiply by 15, and then 3 into 3 into 3 because a cube. See here, and volume is 3-dimensional, so centimeter cube. Now 15 3s are 45, so let us just do it like this. 3 3s are 9, so you multiply this. 9 5s are 45, 4 in hand. 9 4s are 36 plus 4, 40. So the total volume of the structure is 405 centimeter cube. Okay. Finally, one more example before we end this video, and that is your example 13. Important. Okay, so follow it closely. Textbook method seems to be incomplete, so just follow this closely. Okay, so here, let me read the question for us. A cube and a cuboid have the same volume. The dimensions of the cuboid are in the ratio 1:2:4. Please remember they are same volume and the dimension of cuboid is given. So let us 1:2:4 means the cuboid structure is a little bit 1:2, so smallest bigger. Okay. So that will be something like this. See here, 1:2. So 1. Okay, so it will be something of this structure, the cuboid. Here, see, 1. Okay, 1 means 1x, and then 2:4. Okay, so 2:4. So it will be, just let us make sense with the diagram also, so it becomes easier to understand for you. So here this is 1:2 means the breadth is longer than the length now, and the height is the tallest, 4x. 1:2:4x. See? 1:2:4. Check the text. So here, dimensions. Okay, let dimensions, you say, let 1x, 2x, and 4x, let's just put it simply like that, be the length, let us say capital L, breadth, BREADTH, capital B, and the height, capital H, let us say, respectively, okay, respectively of the cuboid that is given to us. Okay, now there is a cube also, so let us just draw a cube. The cube, we don't know what is the H, let us just put it as A. So right here, let A be the H of the cube. Now these two have the same volume, that is clearly mentioned. Okay, now let us go and do the first one. Since first statement of the question says they have, the means both of them, they have the same volume. Please check the question, first sentence, you can see that. Therefore, I can write here volume of the cuboid is LBH will be equal to volume of the cube, A capital cube. Formula for volume of cube will be equal to formula for volume of cuboid, because the question itself is saying they have the same volume. So we can work out something here, that's why we're doing this. L is now, first one, 1x or x into 2x into 4x, and A is A, so just keep it A cube. Now you can just transfer this A cube this side and remove the cube, then this side will come cube root, right? In the curve, inside the curve, cube should be put inside the curve and cube root. So here now, x, x, x triplet. So you write here x into 2x, okay? 2x into 4, you can write 2 into 2 into x. Now that way, this triplet 2 will come single out of the cube root, triplet x will come out single, so A equal to x, 2x. So we found out that the h of the cube is A is 2x, okay? So let us just keep that. Next here, question is saying, if the difference between the cost of polishing the cuboid and the cube, so both are going to be polished. So let us just do here, surface area to be polished. Let us just calculate one by one. Maybe the cuboid first. For the cuboid will be the total surface area, that is 2 into LB plus BH plus LH. They're going to polish the whole total surface area. So we're using that formula for total surface area. So next here, 2 into L is here, 1x into 2x, B is 2x into H is 4x, plus L is 1x into H is, again, H is 4x again. So we write that. So that is 2 into 2x squared. When you multiply these two, 2 4s are 8x squared, and here 1 4s are 4x into x squared. So that is 2 into 10, 14, 14 x squared, 2x squared plus 8x squared. So you'll get 14. So this is 28x squared. Surface area that is of the cuboid that needs to be polished. Okay, and likewise, surface area to be polished. Let us say we're calculating this time for the cube, CUBE. Then we have the formula for surface area of the cube is 6a squared, right? 6a squared. Now we can just put there 6 into a. We found out here 2x squared. So this is 2x into 2x, because a squared means 2x 2 times, right? So this will be, okay, sorry. Now 2 2s are 4, 4 6 are 24, x into x squared. Okay, so this one here, clearly the surface area for that to be polished is more for cuboid. 28 is greater than 24. So next, I'm saying that because the next statement is important. Now the question is saying something, so let us go there and see. Write down likewise. Since the question in the last part is saying the difference between the cost of polishing, the difference in cost of polishing, okay, I'll just shorten it, is rupees 80. Okay, rupees 80. Or we can just write full, no harm. The difference in cost of polishing, difference between the cost, they have written there. Difference between, okay, the cost, between the cost of polishing, between the cost of polishing. So, okay, let us just write the same as it is in the question, then no harm. The cuboid and the cube. The cuboid and the cube at the rate of, I think they're given like that, at the rate of, yes, rupees 5 per meter square, at the rate of rupees 5 per meter square. So I'm just writing exactly as it is the language in the text, so it's easy to write, right? From a question paper you can write like that. It's rupees 80. So this one, we're going to use this one to find out something. So here now, please remember this formula. Cost is equal to area into rate. Okay, area into rate. Cost is area into rate. You need not write this one. Just keep this in mind as you do this. Now here, difference between the cost means surely the cost of polishing cuboid will be higher, right? Because the surface area is more. 28 x squared is greater than surface area. So if you polish more surface area, the cost will be higher. So the word difference means higher cost minus lower cost. So the cost of polishing cuboid will be higher. So cuboid cost minus cube, because difference means bigger minus smaller number. So higher cost that of cuboid. So cost of polishing the cuboid will be area of the cuboid, that is 28x squared multiplied to the rate is same for both, rupees 5 per meter square. So we write here 5 per means divided by, and difference means minus. Higher cost, cuboid polishing cost, minus cube polishing cost is the area is 24x squared. See, multiplied to the rate is same, rupees 5 per meter square. So the question is saying this is the difference in cost. Higher cuboid cost polishing minus cube polishing cost lower. So difference bigger minus smaller equal to the difference is rupees 80. See here is 80. So if you got that, then we can just write the next part here. See, therefore, or that implies, you can just continue. Here just take out the common factor. This is common in both. So let's just take it out to make it easier for us. Rupees 5 per meter square outside the bracket, then inside bracket will be 28x square, minus is there. This is outside bracket, so now minus 24x square is equal to rupees 80. That way these rupees and rupees you can cancel, because here into now if it will go down to denominator and cancel this rupees on the numerator. So next here, next that implies, now you shift this one. 80 is there, then if you shift 5 by meter square will go up, which is down, and up numerator 5 will come down, because this is into, so 5 will go down, meter square will go up. Now once you are left with that, you are left with 28 minus 24 is 4, only this one, so this is equal to this. So next step, x square, and shift the 4 again. Before that, 5 ones are 5, we can cancel, 3 in hand, 5 6 are 30, so 16 there. So x square will be 16, and then this 4 into means coming down again, meter square, so 4 4s are 16. So that implies x means square root over this one 4 and meter square, making sure the root covers everything, which will be equal to 2 2s are will come out single, meter square will come out single. So x we have found out, the main thing. So we'll now get all the dimensions of the cube and the cuboid. So let us just find out here. Therefore, capital L, which is equal to 1x, will be 1 into this x, now we got it, 2 meter, which is here. L is therefore 2 meter. Breadth will be here in the beginning. Now 1 is to 2 is to 4, so breadth was 2 into x, so 2 into 2 meter, which is now 4 meter. And height is here 4 into x, so x just now we got it here, 2. So just put there 2 meter. So we got all the dimensions, 8 meter, length, breadth and height. Therefore, we can easily calculate the volume of the cuboid, right? Because they are saying find the volume of both. So LBH. So this is 2 into 4 into 8 meter cube. So that will be equal to 2 to the 4 are 8, 8 are 64 meter cube is the volume of the cuboid. First answer. And the HA we found out to be 2x now in the beginning. A was 2x. So let us just find out A equal to 2x. We got that in the beginning, right? So 2 into, just now x is 2 meters, so this will be 4 meter now. You see here x is 2 meters, so we're putting there. So the h of the cube also found out. Therefore, very easily, volume of cube that we're using here is a cube, therefore. So let us use, I think we used capital, so a cube. So this is 4 into 4 into 4, 3 times, because a cube. Volume is 3-dimensional, so we just write there, meter cube, okay? And then here, 4 4s are 16, and 16 into 4 is 4 6 are 24 to 64. So 64 meter cube. The statement of the question in the beginning said they had same volume, and that is found to be true here. 64 meter cube volume of cuboid. Cube volume also same, you see. So this is your answer, 64 meter cube, okay? This concludes your video, and all the questions in the exercise 13.5 and all the 3 examples are done. So you can write it down and recheck the video to understand it better, okay?